I think, remember we talked about last time, you have to be careful when you're doing these in the book because your answer might look different from the answer in the book and still be right because it might have been drawn in a different orientation. On the other hand, you can't assume it's right. You really have to go very slowly, pointing to each atom with your finger and make sure that the picture that you have is the same as the correct answer. You don't want to be easy on yourself there. All right, so this is one good way to draw this here. Oh, so let's take a look at the alcohol oxidation and reduction handout again. You have that in front of you? So what's the name of this functional group? Because the carbonyl carbon is attached to 2 carbon chains. Good. So let's find where we are on page 1 of that alcohol oxidation and reduction handout. Where's the starting material? Good. And where did we move to on the handout? Yeah, we moved down into the left. Did we really make a tertiary alcohol? Did you check your picture? Yeah, we really did make a tertiary alcohol, just like the handout says would happen when you had R-. Okay, was this then an oxidation or a reduction?
Reduction.
Yeah, that was a reduction. A reduction that added an extra carbon. So it's always a good idea to kind of follow along after the problem on the handout to see how we're moving through there. Okay. All right, now that I think we've got the Grignard down, now we can start doing some synthesis. All right. Okay. So here we have a synthesis problem. For a synthesis problem, we're given the starting materials and the product, and we have to come up step by step with reagents that will take us from the starting material to the product. Okay. Any ideas how to get started on this? Good. Now, how do you know that those correspond? I think we talked last time about how a good first step is to look for a landmark, something that you know is the same in both pictures. So what's our landmark here? The oxygen is our landmark. So we know, or at least we can guess, that the carbon that's attached to the oxygen here will be the same as the carbon that's attached to the oxygen here. You never know for sure, but that would be a good guess. So you decided to give this oxygen, this carbon the number 2 number, and then we should put that same number over here because these are the same carbons. And then you call these 1, 2, and 3. Is that right? So we want to keep numbering any carbon that's the same in both pictures. All right, so that's a good start.
We have to add a carbon chain. So the Grignard first.
Now these carbons don't correspond to anything in the starting materials, so they should get brand new numbers. That's good.
Can I number that? I can't make a,
I'm sorry, what was your question?
like 4, 5, and then I can't put 6 and 7.
Why not?
Because I have to, because it's not in order, right?
I think that you're thinking as if those were IUPAC numbers,
Yeah,
right?
so you can't.
Remember, these are not IUPAC numbers.
Yeah.
These are not the official IUPAC numbers. They're just reference numbers. So you can give any numbers you want. Remember, we could have called these Bob and Alice if we wanted to. Okay, so what number do you want to call this one?
6,
Yeah, and this one?
7.
Okay, yeah. So since these are not IUPAC numbers, you can use whatever the heck numbers you want, as long as if you give a number to a carbon in one picture, that same carbon should get the same number in the other picture. Okay.
But I can't make, can I make a chain of these 4 carbons? Like if I want to do a Grignard,
Right.
and I have 4, 5, 6, and 7 in the same chain.
That sounds good to me.
Is that right? Or is
Okay.
that first? I mean 3.
right, so this is your guess as to what the first reagent would be. Now, the thing we have to do is keep numbering. We want to put numbers here that would correspond to these. And when you try to do that, you'll see it doesn't work. For example, what number do you want this to be?
4.
And then what would this be?
5.
And this?
6.
Okay, and this?
7.
But you can see that doesn't work because these are supposed to be the same atoms, right? So is the 4 really connected to the 5? Yeah, that's fine. But the 5 is supposed to be connected to both the 6 and the 7. The 5 is supposed to be connected to both the 6 and the 7, and it isn't in this picture. Well, that just proves that this was not the right reagent to add. If we add this reagent, we won't get a picture that looks like this. So we have to keep numbering all the pictures, not just the pictures we're given, but also the new pictures that we're coming up with, basically. Okay.
I didn't think it was right, but I didn't know it
Yeah.
was right.
No, that's fine. Okay, so, but the key thing is notice how the numbers help us to diagnose when it's wrong. Well, let's see what a good technique would be here. Let's use one or two of the other techniques that we talked about last time. Can you identify what's one of the atoms that's undergoing some changes here? What's an atom that's gaining or losing bonds between the starting materials and the product?
The second one.
Number 2. Yeah, which bond is it losing?
It's losing a bond with the oxygen.
Losing the pi bond. Do you remember our squiggle technique? Let's put a squiggle in for a bond that's forming or breaking. Okay. Let's see then. So what was the new bond that the number 2 formed over here?
With the 4 carbon.
All right, so that squiggle technique here is going to be helpful to us. All right, so far I'm just using the redraw and modify technique. I've just redrawn this picture over here. Now there's no squiggles on these bonds, so these are all the same. Although actually I guess you can put in some extra squiggles. This is a new bond too, right? That bond doesn't appear in this picture. All right, so that one should also have gotten a squiggle. So maybe I won't put that hydrogen there. Okay, so this is what the number 2 carbon looks like in this picture. So how should I draw the number 2 carbon over here? What should it look like here?
Like that.
So what I mean is, well, let's see. So here we have an alcohol. So just describe in general terms, what type of reaction is happening here? A reaction between what 2 things that's going to give us this?
Between a ketone and, I mean, what's it becoming?
Yeah, that would be one good thing. Yeah, what's it becoming? Yeah, an alcohol. So one of our starting materials is the ketone. What's our other starting material going to be? What do we have to add to a ketone to get an alcohol? I think you actually already had this figured out a couple seconds ago. Maybe you've forgotten. So
Grignard?
yeah, that's what you already figured out, right? Definitely not PCC. Okay, so what we want to add, so it's not a ketone plus PCC that takes us to here. It's a ketone plus a Grignard. Okay, so
What was the PCC doing earlier? What were we attacking? We're doing.
now the PCC is an
oxidation. Okay.
yeah, that's oxidizer. That attacks alcohols. Okay, so we need a ketone plus a Grignard. So where did this part of the molecule come from, do you think? From the ketone or from the Grignard?
Ketone.
Okay, so my question to you was, I was asking you, what did this look like before it became the product? And the answer should have been, it looked like a ketone. So it didn't look like this. It looked like this. That was kind of the answer to the question that I was asking you. What does this look like? Remember that we're trying to use this retrosynthesis idea of working backwards from the product. We're asking what starting materials or intermediates would have given us this product over here. Okay, well, starting with this starting material would have given, so this product would have come, this piece would have come from a starting material that looks like this. This is not the normal way we draw a ketone, but that's okay. All right, and then what do we have to react the ketone with? A Grignard. We already said that. So what type of functional group did this was this portion before so here's the other portion on the other side of the squiggle. Well, what type of functional group was this before it turned into the product?
A Grignard.
It was a Grignard. Okay?